Welcome to the Arduino MATLAB connection class. In this video you will learn how to manage input and output signals in MATLAB, for example, to read and write analog and digital signals in Arduino, how to perform data acquisition and control servomotors. The outline is divided in 4 parts. First, the Arduino I/O function for MATLAB. Then the analog and digital input and output management, following by a data acquisition setup example, and finally the control of servomotors. Let's start with getting the toolbox. You have 2 options to get the function: in Blackboard in the section of MATLAB tools or directly in the file exchange webpage of MATLAB. Once you download it, put the uncompressed directory in your MATLAB documents. To install it, you have to execute the install Arduino file. The server sketch is a finite state machine that continuously runs in Arduino. It listens for commands arriving for the serial port, executes the commands, and if needed, returns an answer. There are 5 different server sketches in order to increase complexity. The first covers only the analog and digital inputs and outputs and the basic serial communication. The second includes the manager of encoders, and the last one includes the servomotors library. 2 more sketches designed for Adafruit motor shield are included too. In the folder PDE of the toolbox, find the sketch with servo support and open it in the Arduino IDE platform. In the tools, select the board type. In this case is the Arduino Uno in the serial port. Then just upload the sketch in the Arduino board. To create an Arduino object in MATLAB, use the command arduino to specify the serial port used, COM3 in this case. Once the Arduino object is created, we need to configure the function of the pins that we will use, using the command pin mode with the number of the digital pin and a string that defines the operation mode of it. Some examples are presented in order to clarify the syntax. To describe the analog and digital input outputs, we will start with the digital outputs in MATLAB. Once you configure the Arduino digital pin as an output, use the command digital write with the pin as the first argument and the logical state as a second argument. Some examples are shown. This is electrical connection to turn on and off a LED connected to the digital pin 3. Previously configured as output. This change is known to as a logic high and logic low levels, turning on and turning off the LED. To use the digital input, use the command digital read. This returns a value 0 or 1 of the digital pin previously configured as an input. To store it in a variable, use the syntax of the examples. This is the electrical connection to read the status of a push button connected to the digital pin 12. This is a normally open button. Without push it, the state is 0, and pushing it, the state is 1. This script in MATLAB is an application example of the digital input and output signals. The code will read the state of the button, and then we press it. The LED will turn on just 5 times. Now we will cover the analog output signals that work on the digital ports using a PWM signal. Use the command analog write with the pin numbers as a first argument and the value as a second argument. The value must be between 0 and 255. The examples shown the syntax. This is the electrical connection to write the value of the digital pin 3 to vary the intensity of a LED. Put attention on the LED. As you can see, the intensity of the LED changed from 90 value to a 10 value and 210 value. This MATLAB screen contains a routine to show the intensity variation of the LED that go up and down 4 times. The analog read task is performed in the analog port of Arduino. Use the command analog read with a pin as argument. The example shows the syntax. The returning value varies from 0 to 1023. This is the electrical connection to read the voltage variation from a potentiometer connected to the analog pin 3. The reading value depends on the position of the potentiometer. This MATLAB script shows the intensity variation of a LED depending on the value in the potentiometer during 10 seconds. To disconnect the Arduino board and close the MATLAB session, use the command delete as shown in the examples. Using an analog signal that can be obtained by a sensor varying the voltage, we can store and measure the values during a certain period of time and visualize it in MATLAB. The MATLAB script is intended to show a tool to acquire data and put the voltage variation on a plot. The scale is designed to get the maximum value in 5 volts, that it is the input voltage used, and 0 volts as a minimum value. Varying the position of the potentiometer, we can introduce data in MATLAB from the analog port of the Arduino. Another useful tool is the control of servomotors. Servomotors come already packaged with a rotation sensor that usually is a potentiometer and a control unit. The reference position is communicated to the control unit by a PWM signal. The Arduino has an active servo library which allows a servo to be connected to any digital PWM pin. To configure a servo, you have to attach it using the command servo attach with the corresponding PWM pin as the example shown. To send an angle to the servo, we use the servo write command using the number of the pin and the value in degrees, usually from 0 to 180. To read the angle of the servo, we use the servo read command just specifying the pin. To detach a servo, we use the detach command. We attach a servo in the digital port 6 that allows PWM and send it to 10 degrees, 120 degrees, 180 degrees, and 5 degrees. The MATLAB script runs a routine to move the servo from one side to the other 3 times. Thanks for watching.